Good morning class. Today we are going to start our new chapter, that is chapter number 3, matrices. First of all, what is matrices? Matrices is a plural word, right? Now we have to find singular word. Singular word is matrix. Now what is the meaning of matrix? First of all, the definition says a matrix is an ordered rectangular array of numbers or functions. What is an array? Array is a combination of words which is taken in a rectangular manner, and it must be ordered, right? It must be ordered. It has some order, right? That is why it is ordered. Ordered rectangular array of numbers or functions. So the elements of that matrix will be what? Numbers or functions, because it is an ordered rectangular array of numbers or functions. So that matrix will contain either number or functions. The number or function are called the elements or entries of matrix. What that and that are called matrix entries or elements. Elements or entries of matrix, which the number which we will use in the matrix, right? That numbers will be called elements or entries of that matrix. Now I have 6 numbers 1, 2, 3, 4, 5, 6. I have to arrange them in a rectangular manner. So many ways will be there. I can arrange all them in one row or in one column, or 2 rows and 3 columns, or 3 rows and 2 columns, right? So these are the ways to arrange the 6 numbers. So one of the way is taken here. 1 is our first element, 2 is our second, 3 is our third element, and 4 is our fourth element, 5 is our fifth element, and 6 is our sixth element. Now here we used is 3 rows and 2 columns. So this is what? This is a rectangular array of numbers or functions, right? So this is what? This is a matrix, right? Next example, I will talk about this later one, right? Next example says we have 4 functions: tan theta, cot theta, secant theta, and sin theta. You all are aware about this: tan, secant, cot, and sin, right? We have to arrange them. Arrange the 4 functions. We have 3 ways: either 4 in one row, or 4 in one column, or in a rectangular manner of 2 cross 2. 2 cross 2 means 2 rows and 2 columns, right? So I have arranged them: tan theta, cot theta, secant theta, and sin theta, right? So these are the examples of matrices, right? Next I am going to talk about this, which is order of a matrix. Order of a matrix. What it says: a matrix of rows m and columns n, right? Means a matrix having rows m and n columns. It will be a matrix of order m cross n. So we call that matrix as of order m cross n if it has m rows and n columns. Then only it will have order m cross n. Now see here, how many rows this matrix had? This have 3 rows. This matrix has 3 rows. And how many columns? 1 and 2. So 2 columns and 3 rows. So it will be what? 3 cross 2. The order of matrix will be 3 cross 2, which is written here. So for the rectangular matrix, order will be written at the bottom right corner, right? Next is 2 rows and 2 columns. So we have 2 rows and 2 columns. So order will be what? 2 cross 2. Now here one more example is there. They said a matrix A with 2 rows and 3 columns will be of order 2 cross 3, right? I think you all are clear about the order. Next I have defined a general matrix AMN with m rows and n columns. So here are the entries. A11 means first element, A12 means second element, A13 means third element, A1n means nth element. Similarly, A21, A22, A23, A2n up to so on AM1, AM2, AM3, AMN. Now see what we did. We did is A11 means first row and first column. So first entry corresponds to first row and first column. Next is first row and second column. first row and second column. So we change the column and moving in the same row. So A1, 2. First row, third column. First row, third column. We change the column again and we are moving in the same row till n, because n columns will be there. Till A1 n, right? Because n columns will be there. Now we will do is what? We will change the row, because how many rows we have? M rows, right? So now we will change the row 2 and column 1. So the entry A21 corresponds to second row, first column. A22 corresponds to second row, second column. A23 corresponds to second row, third column, and similarly so on. So here we have moved up to M rows, and totally we have M rows only. So this entry will be mth row, first column. This entry will be corresponding to mth row, second column, mth row, third column, and last mth row, nth column. I think you all are clear with this, right? Now I will tell you about the types of matrices. Before that, I have one special note. They said a matrix of order m cross n will have mn elements. Any matrix of order m cross n will have mn elements. We can see here also 3 cross 2 means 6 elements. 1, 2, 3, 4, 5, 6. 2 cross 2 means 4 elements. 1, 2, 3 and 4. Right? So this is the general thing. Next we are going to talk about the types of matrices. This is an easy topic. Column matrix. First type is column matrix. A matrix is said to be column matrix if it has only one column. If it has only one column, what type of order will be there? We have m cross n, right? M cross n. If columns are 1, it will have order of m cross 1. M can be any number, but column is only 1. So its order will be m cross 1. So one of the example is there, a matrix of order 3 cross 1. See, 1, 2, 3 rows and only one column. So this is what? This is the example of column matrix. A matrix is said to be column matrix if it has only one column. Only one column must be there, and its order will be of the type m cross 1. I think all of you are clear with this. Next type is row matrix. Similarly, according to row matrix, according to column matrix, a column matrix is having one column. So similarly, row matrix will be a matrix of row 1, right? If it has row 1, then which type of order it will have? M cross n. That means m is our 1, so it will be 1 cross n. 1 cross n. So here we have one example which is a row matrix. 1, 2, 3. 3 columns are there and only one row is there, right? So we have a row matrix with order 1 cross 3, right? Next is square matrix. Now as the name only depicts, square matrix. Square means it must be not rectangular, it must be square. And when a rectangle becomes square, when length is equals to breadth. And length and breadth for matrix corresponds by number of rows and number of columns. So if length is equals to breadth, that means number of rows must be equals to number of columns. So that is what? That is a square matrix. A matrix in which the number of rows is equals to the number of columns is called a square matrix, right? Here we have one more example about the square matrix. 1, 2, 3, 1, 2, 3, 1, 2, 3, right? 3 rows and 3 columns, and the order of matrix is 3 cross 3. Number of rows is equals to number of columns. That means what? That it is a square matrix, right? Clear about third one? Now coming on to fourth. They are saying fourth type is diagonal matrix. A square matrix is said to be diagonal matrix if all the non-diagonal elements. What that mean? That diagonal elements are not included. All the elements must be 0, right? And first of all, it must be a square matrix. Why it must be a square matrix? If it will be rectangular, then what will be the case? Because in rectangular matrix, we can't define a proper diagonal, right? In square only we can define a proper diagonal. In rectangle, we can't define a proper diagonal. See here, Can we define a proper diagonal? No, it is not possible. So it will be possible in square matrix only, right? So a diagonal matrix first of all needs to be square matrix. So a square matrix is said to be diagonal matrix if all of its non-diagonal elements must be 0. So here we have one example 1 0 0 0 2 0 0 0 3. See here, this is the diagonal. Diagonal elements are 0 or non-zero, we don't have to worry about it, but all the non-diagonal elements must be 0. And you can see other non-diagonal elements are what? They are 0, right? So this is what? This is the all the types of matrices, and we will talk about next types of matrices later in the class, and we will discuss some more examples of these type of matrices. Thank you, and we'll meet you in class.